Okay, hi guys. So in this lecture, we'll be discussing on the experimental determination of order of reaction. So let's get started. Experimental determination of order of reaction. So first is heat and trial method, which is also known as integrated equation method. Heat and trial method, also known as integrated equation method. So you have been given the initial concentration at A, and after let's say time t1, t2 and t3, you find the concentration as m1, m2 and m3. So from these, so better let's say x1, x2 and x3, because we have been using the same variable, so for the consistency sake. So if it's a zero order reaction, then we will have x as kt. Okay, and if it's a first order reaction, we would have k equals to 1 by t ln a upon a minus x. Okay, so case is, let's assume that the order of reaction is 0. So let the order of reaction be 0. So if it's 0, then k1 would be x1 upon t1, k2 would be x2 upon t2, and let's say k3 was x3 upon t3. Now if we get that k1 equals to k2 equals to k3, then our assumption becomes correct and the order of the reaction is indeed 0. Okay, and if we have k1 almost similar to k2, almost similar to k3, due to this can be due to experimental error. So in this case we can have k average as k1 plus k2 plus k3 over the 3. This will become the rate constant for the zero order reaction. Now let's say if we have case 2, in which we have let the order of reaction be 1. So in this case what we can say is, if the order of reaction is 1, then k1 can be calculated as 1 upon t1 ln a upon a minus x1. Similarly k2 can be calculated as 1 upon t2 ln a upon a minus x2. Similarly k3 can be calculated using the same formula. Then if we compare k1, k2 and k3, and if they happen to be all same, then our assumption is correct and the order of reaction is indeed 1. Next we have is the graphical method. For finding the order of a reaction, so graphical method is, for zero order reaction we would have the graph something like this. Between x and t, x is the concentration of the reactant that is dissociated, or the concentration of the product which have been produced after some time t. Then if it's, the graph is something like this, then it would be a zero order reaction. This is obviously timestamp for completion T completion is there, would be there at this x-axis of time. Okay, or we can also have graph something like this, a minus x, this is by the way x, a minus x with t would be actually decreasing, and finally at t complete we would have a minus x as 0. Okay, so if these two graphs are observed, then the order of the reaction is 0. What about first order reaction? So in first order we would see the graph something like this, that if we see the graph of ln1 minus x over t, then it should have a negative slope. Or we can also have that the concentration of reactant with time would be decreasing, and the nature would be something like this. Or if we have a graph something like this, where the concentration of product with time is increasing, again with a curve like this, then it would be a first order reaction. And the third method is the half-life method. So we know that T half is proportional to 1 upon a, inversely proportional to a to the power n minus 1. This we have seen in the previous lectures, so we will be leveraging the same, and we will be carrying out our experiments. Something like if we get A1 at half-life 1 and A2, let's say, at half-life, so this is experimental 1, in which we get the concentration as A1, so we call it as T half 1, and experimental 2, when we have A2 as the initial concentration and its half-life is A1 by 2. Subscript 2, we are just, subscripts are there just for differentiating the two experiments in which we take different initial concentrations of the reactants. Okay, so using the same we can check if how is T half varying with A's power. So if we take the ratio of T half 1 with T half 2, we can say that ratio would be A2 upon A1 to the power n minus 1. Okay, and from this we can simplify it by taking ln on both the sides, so it would be T half 1 over T half 2, that should be equals to n minus 1 ln A2 upon A1. So we can write n equals to nothing but ln T half 1 upon T half 2 divided by ln A2 upon A1 plus 1. So with this we can calculate the order of the reaction. Okay, so with this we come to the end of this lecture. In the next lecture we will be seeing one more method, which is ratio variation method. So till then, good luck and goodbye.